Thank you all for being here today. I really appreciate you taking the time out of your day to sit in on this seminar, especially as we continue to support and celebrate Citizen Science Month here at NOAA. April is Citizen Science Month. We've had a couple fun initiatives and activities going on throughout the month, including a new external website on NOAA.gov. So if you haven't checked that out, please take a look at it. All right. So today I'm going to be presenting on a project I've been working on and off for the past 2 years on getting started in citizen science. This project is a compilation of my work from my master's program in instructional design, and it involves the previous work I did at Public Lab as a community scientist, as well as the work that I've been able to do at NOAA since joining the team in 2023. So I'm briefly going to mute my camera so you all are able to see all of the content on my slides. I don't want you all to miss anything, but let's get started. So today we're just going to do a brief introduction of myself. I've already done that a little bit. We're going to talk a little bit about citizen science, even though I realize many of you are probably well versed in the practice. We're going to take a look at the project planning tool I came up with as part of my master's program. I'll walk you through an example project that I completed prior to joining NOAA, and then we'll have some time at the end for questions. Again, just a brief background on me. I currently live in West Virginia. I'm a very proud graduate of West Virginia University with a bachelor's in Wildlife and Fisheries Resources. I just graduated last month with my master's in education from Western Governors University in Instructional Design, and this presentation is the result of that master's program. After completing my bachelor's degree, I participated in the AmeriCorps program, which was a very unique program run on Jekyll Island, Georgia, through the Georgia Sea Turtle Center. I'm also the former education manager at Public Lab, which is a community and citizen science-based nonprofit organization. And I'm currently the Citizen Science Program Support Specialist for NOAA. So I realize that I may be speaking to the choir here. I have a lot of members of the citizen science community tuning in today, but my goal through this week was to help to recruit new members from all walks of life. Citizen science can go by many different names, such as crowdsourcing science, participatory science, or community science, but they all have the common theme of community members taking on an active and participatory role in the scientific process to address real-world problems and expand knowledge. This can look like individuals sharing local weather reports across the country, or a neighborhood experiencing flooding after storms and reporting their own observations and data. Many of these topics are things that people are experiencing in their local communities and issues that they can help to advance and support. While completing my master's program, we were challenged to identify an issue in the workplace that could be resolved through the creation of training or instructional tools. Through my work experience, I've come into contact with numerous individuals who didn't know what citizen science was. When I explained to them what citizen or community science looks like, they got very interested, but either their lack of education, their lack of experience, or the lack of guidance was a barrier that prohibited them from being able to participate in the process. I've come into contact with numerous individuals who are interested in citizen science or are passionate about an issue they're experiencing, but they lack the guidance or training on how to start a project. And this was a huge barrier that kept them from getting more active in resolving issues within their community. So while working on this project, I found several tools and resources that would help support budding citizen scientists. I tried to compile several of these ideas and strategies into a planning tool for organizing a new project or program that would help to alleviate some of the stress of how to organize a project. Some helpful resources I frequently utilized came from the Environmental Law Institute, who have a truly amazing collection of tools and resources designed specifically to support citizen scientists. They have case study examples. They have a best practices guide. There's also a lot of other great web-based resources. Community-based crowdsourcing websites like Public Lab, my former institution, even though they are no longer a staff-funded organization, their website is open and operational. If you've never looked at it before, imagine Reddit, but with an environmental focus and passion. It's crowdsourced sharing of data, tools, and resources with citizen scientists from across the globe. I also created a citizen science planning map, which we will be reviewing as part of this presentation. But I just wanted to dig a little bit deeper into one of the resources from the Environmental Law Institute that I found particularly helpful. This case study booklet includes examples based on citizen science programs from across the United States in a few common environmental categories such as air quality, soil, or water quality. Each category provides project examples and outlines the issues and work being conducted by citizen science groups on the ground. As you go in and you can click on the specific projects, it will bring up information about project leads, groups working on this project, what obstacles they encountered while working on these issues, and the ultimate result at the completion of their study. So this was really helpful to look through. And it's also really great to show other citizen scientists, because when you're experiencing an environmental issue, it can feel very isolating and alone. And sometimes it's nice to see that other communities are experiencing a similar issue, as well as the fact that they were able to work towards a solution or overcome that issue. So this was particularly helpful to go through. So the next few slides, we're just going to be taking a look at the graphic organization tool that I came up with in my master's program. It's split up into 3 phases that cover a broad overview of the issue being studied and gradually get more specific to identify needs and objectives in the planning process. So on page 1, an important thing when undertaking a new project, arguably one of the most important things, is to identify the issue and describe it in your own words. One of the most important things a citizen scientist can do is describe the issue that they're experiencing in their own community. How has the issue changed over time? Who is being impacted? I am very passionate in saying that citizen scientists have the unique asset of anecdotal experience on many of these issues. Because they firsthand see the changes over time, they feel the direct impacts of these changes, and that home-based knowledge is a valuable resource in planning and documentation. The next step would be to identify potential stakeholders. Are these local businesses or community groups that are also being impacted by the phenomenon? They may want to help you collaborate, or they may have other tools or resources that you could use to conduct your research. They may have a meeting place where you can gather together with other citizen scientists, and they can help you look for potential partners. Potential partners could be local nonprofit groups, local government agencies, even community groups or schools that could help you collect that data. Next up is to identify the long-term goals for your project. Is it to bring awareness on the issue? Is it to find a solution for the problem? Or is it to create an actionable change? Finally, an important factor to planning your project is identifying any previous work or research done on the issue. You don't want to lose valuable time and money reinventing the wheel. So if there are other folks conducting similar research, it can be really helpful to pool resources and put even more emphasis behind the issue and amplify that voice. This can bring about better momentum for causing change. At this point, you'll want to search for existing work and projects to see what type of data has already been done or collected. All right, in phase 2, you'll be identifying necessary tools and resources that you will need in order to collect your data. For example, if you were studying flooding or a weather-related issue, you might need tools like a rain gauge or aerial mapping to look at your area. Do you also have the technological needs like laptops or specialized software, things like GPS or GIS that could be important for collecting these resources? Next up is one of the most painful, but also one of the most important, and that's looking at your funding options. Do you need money to buy these tools, or could you get them donated? Will you need to hire staff members in order to help you analyze, process, collect data? Are there fees associated with that? Funding can be solicited by conducting a fundraiser or also by applying for grants through government agencies or foundations. Planning out your research. How will it be analyzed? What measures are being taken to ensure that the data collected is credible? How will it be shared throughout the team to ensure that everyone has access to the materials as well as the numbers and figures being collected? Another important need is to identify whether or not you'll need site approval or permits. Even though a lot of these projects are geared towards serving the greater good, sometimes you'll need a special use permit in order to access land. For example, if your studies are being conducted at a park, you may need a special use permit by a government agency to access certain regions that might be outside the general public access. If you're studying a waterway, you might need permission from a landowner in order to access the stream or river you're studying. How will you share your results? Will you start a website to connect yourself with other stakeholders impacted by the issue? Or is your ultimate goal to be published in a scientific journal? For the last step of this phase, you'll be conducting a workflow timeline. Here is where you'll outline how much time you think you'll need to conduct your study project. This can be short-term, lasting just a few weeks, or it can be long-term, lasting several years. For example, weather-related issues may require several seasons or even years in order to establish a baseline, as well as to collect enough data to identify patterns. And this is where I'd like to mention that this is just a tool. Nothing is set in stone. Research is not always a linear path. Like any good experiment that follows a scientific method, you will need that time to revise your plan as situations arise. But this timeline is good to hold the team accountable for meeting deadlines, especially for projects that solicit grant funding. All right, final phase, phase 3. In this last phase, you'll plan out how to hit objectives, particularly if you do secure grant funding through private entities, stakeholders, and foundations. Sometimes these funding opportunities may have different requirements in order to fulfill the contract to secure funding materials, such as quarterly or seasonal grant reporting. Many grants also require presenting at conferences or other community events. The last step is optional, but would be an action plan. By this point in our citizen science project, we worked very hard on an issue that they are passionate about. How would they like to go about eliciting change? What are they going to do with this content after they've collected it and they've formed their findings? Let's see. So next up, I'd like to walk you all through a project that I completed prior to joining NOAA with my previous organization, Public Lab. We work particularly with a community of students and families along the Mississippi River down in New Orleans. We particularly worked with secondary science students at a few of the schools in the area, studying the health and water quality traveling down the Mississippi River. For this project, we worked with students to show the importance of field research and investigation, increase science literacy, as well as take them through the design of an action plan. So this is an example of what this graphic design tool would look like in the context of this project. I won't read everything word for word, but just a general overview of how things are organized. So for this one, we identified that studying the water in the Mississippi River, particularly in that area, was important because over half the population in that area receives their drinking water from the Mississippi River. These families, communities, and kids are disproportionately impacted by degraded water quality coming down the river. There are issues with a lot of debris and contamination that flow downstream from the headwaters that go through residential, commercial, and industrial areas. The local partners consisted of the municipality, local riverkeeper groups, as well as several local parks that granted us access to lands, and they helped us support that the program. In phase 2, we assessed what equipment students currently had access to at the schools and what they might also need. We also had to take into account other restrictions such as transportation and class time, as well as having access to a science lab for processing samples. We determined that students needed things like sampling gear and microscopes in order to collect and process specimens collected from the river. They also needed access to smartphones or tablets that could support the use of the Marine Debris app. They also needed internet access because they were sharing their findings online on publiclab.com or publiclab.org with other students throughout the watershed, and they were comparing the data and the findings that they got from their sampling efforts. Another interesting addition that we had to revise our plan to include in this phase was the need for a lifeguard. Because we were working with K through 12 students, the school district had a requirement that anytime students came into contact with water deeper than a puddle, there had to be a lifeguard on duty for water safety. So this is an example of a revision that was made later in the project timeline that we had to incorporate later. For this project, they were able to secure a grant through the EPA, as well as finding support from local businesses and a private foundation. For the workflow timeline, we identified times that teachers and school staff would be able to receive training. For a lot of them, this was their first time doing field research as well, and it was their first introduction to citizen science. So we had to give them specialized training on how to use equipment and the technology needed. They got experience working with the Marine Debris app, looking through its features and functionality. With feedback from the teachers, we identified when would be the best time in the curriculum to introduce the unit to students. And then after getting permission from landowners to access the waterway, we were able to schedule transportation to take the students out to the sampling location. And that allowed us to plan out when students would need to access the school labs to process specimens. And then further on down the line, it allowed us to plan as an organization when we would be able to present our findings at conferences as stipulated by the grant. In the final phase, phase 3, as stipulated through the grant funding, we had to present in 2 conferences relevant to the resource area. So we presented at the National Science Teachers Conference as well as the National River Keepers Conference. For the work of this project and for the students of Public Lab, an action plan was necessary. So doing something with the materials found in order to elicit change. We encourage the students to come up with a creative and meaningful way to change their community based off their experience, which also shows students how data and the work they generated could be used. They elected to use the debris found from the water samples to generate an interactive art exhibit as a visualization of water quality issues. Now, I showed one of these pictures earlier, but this is a close-up look of what some of that art display looked like. The project title for this program is called Messages from the Mississippi. Mississippi River travels thousands of miles and dumps out in these kids' backyards, and their whole lives revolve around the river. A lot of them, their family has grown up in the Mississippi River area, so it's very impactful on their lives. What you'll see are a series of bottles. In each bottle, there is a note that students wrote about how the Mississippi River has impacted them, what it means to their life, what it means to their families. And then everything else you see floating in the bottle is debris they collected from their water quality sampling. So these are literally the messages in the bottles, including their personal messages, as well as the message that the river delivered back to them. This exhibit traveled around to the different conferences we attended as part of Public Lab. It also was on display at a local STEM museum in New Orleans that the kids, their families, as well as their community members could come see as well. Now, with this interactive art display, students were able to work towards creating change within their community. They use this to solicit their local school district for more recycling opportunities in and around school campuses to cut down on the amount of plastics, debris that were going into the local waterways. Now, as I mentioned, this tool was generated as part of my work as a master's student. I was required to test this project out on a sample group to see if it was a viable tool for resolving a learning issue. For this program, I worked with a sample of 11 adult participants. They had varying levels of education and backgrounds. Some were familiar with citizen science, while others were experiencing it for the first time. They started out the unit by taking a pre-assessment to collect data on baseline knowledge on the topic. We had a webinar on the background of citizen science, as well as the status of current government efforts, such as the Citizen and Crowdsourcing Science Act. I walked them through the planning tool, showed them examples of what it would look like in practice. And they were also charged with using a blank project planning tool to create a communities or a citizen science project that would benefit their own neighborhoods. At the end of the session, they took a post-assessment on the same content covered in the pre-assessment. And on average, we see that participant understanding of citizen science fundamentals, as well as the planning process, grew by at least 20%, which I think is a notable increase, especially considering that not all of my participants were new to citizen science. Of my participants, 2 are instructors at colleges in the sciences field, so they have been doing citizen science previously, and they even charted notable growth and change in the topics while going through this unit. They express interest in using the project planning tool with their students in classes and clubs that they help to facilitate at their own institutions. And on a fun note that I take great pride in, a few of my participants from the test group have found citizen science programs in their own regions that they have started participating in and sharing data, specifically sharing data on earthquakes and extreme weather. But by participating in this process, they were more aware of what citizen science is, how that data can be used, and felt more inclined to get involved. They also mentioned that while they may not have had background or formal education in science, they were curious and wanted to be able to do more, especially after having real world experiences. One of my participants in particular lives out in California, and she experienced her first series of earthquakes. Afterwards, they were collecting data from citizen scientists about what they observed, what they noticed, what times, that kind of data on citizen scientists about their experiences with the earthquake. And she was very excited to tell me that she's been able to contribute data for the first time. Overall, they felt like contributing to citizen science programs fostered that sense of inquiry and allowed them to be involved in the scientific method, even as a contributor. So it's helping to break down some of the barriers to participation and engagement with science. Just wrapping it up, I just want to give a special thanks out to the folks who helped me complete this project. John McLaughlin and Laura Armelin, my team here at NOAA, they helped me with the citizen science initiatives within our organization. Alana Moore, who was one of my former colleagues at Public Lab, she is also still working to keep the messages from the Mississippi program alive in the New Orleans area, so definitely worth checking out. Christy Jenkins was my academic advisor and mentor at WGU. Definitely grateful to NOAA, as well as my contracting company, ERT, Earth Resources and Technology. And then I'll be happy to answer questions, but at any time, if you all have any questions or you'd like to take a closer look at some of my resources and would like links, please feel free to email citizenscience@noaa.gov.
Rebecca, thank you so much for such a fantastic presentation. We are going to move on to some Q&A. So the first question we have says, if you could give just one recommendation to someone looking to start a new project, what would it be?
One of the first things I would do, it's very general and vague, but I would search the area. So if you are experiencing something like, oh man, well, like yesterday, I got cut in all that traffic on 495. And I know this is not citizen science, but I just did a very general search of 495 traffic because I wanted to know who to blame. Why am I sitting on the interstate? And it brought up a series of news articles. It also brought up other reports. So whenever you're interested in a citizen science project or just looking to see what's out there, a general search just to see what's going on in the area is helpful. Growing up, most of my work in the back has been with sea turtles. So I would say one of the previous projects I worked on was looking at the impacts of fire ants on nesting and hatching loggerhead sea turtles. So doing a general search of fire ants and sea turtles, either by species or by region, and it'll bring you up scholarly articles that may have already been published. It could bring up news articles of work that's currently going on, but it lets you know who the key players are in the game, what work's already being done. And if you don't find anything, you know that this is an avenue that needs to be explored a little bit deeper. So it kind of helps to scope your work, find out who could be a player on your team, as well as figuring out how much work or how much ground needs to be covered on a new project.
Great. Thank you so much, Rebecca. All right. We have a bunch of questions here. So this next question is from Emma, and she says, "This is excellent. I'm wondering if you have any insights on how to keep project leaders accountable to their volunteers when it is a long-term project with long gaps or intermittent results."
That one's definitely challenging. I would say that I've been fortunate that I still feel like I'm pretty new in my career. So I've participated in some projects that have lasted the span of a few years, but I realize that there are some that have been going on for a very long time. Having benchmarks and deliverables is something that I've seen been very helpful in projects that have spanned the 2 to 3 year period that I've been working on them. I know I'm trying to think of examples from previous positions. Having check-in meetings as well as connecting yourself with the community being impacted. If you were, I want to say, one of the science minds who are behind the scenes working with the data, sometimes it's easy to get disconnected from the folks who are the front lines being impacted by these issues, but holding yourself accountable to checking in with their communities because they're going to renew that passion in you and why you're working to resolve this issue. They can also provide updates that they're seeing. Is this phenomenon changing in any way? I'll just use the example. I recently went to the Voyages for Justice conference in February that NOAA put on, talking about environmental justice and equity. And one of the presentations that they spoke on was a community in, I believe, the Philadelphia area that's experiencing catastrophic flooding. And these folks have been talking about how the past 30 years, every time it rains, they stay up all night because they're afraid that their basements and their homes are going to experience this catastrophic flooding. It's an issue that's been going on for 30 years. And, we have a lot of government agencies that are actively working on creating viable solutions, but these things take time. But checking in with those community members is a great way to figure out if anything has changed, but it's also a great way to keep yourself inspired in the program. So I definitely holding yourself accountable to those impacted communities, I think is a very powerful motivator.
Great. Thank you, Rebecca. All right. Our next question is from Robert, who's asking if you have any sources or advice for advertising to engage a good number of citizen scientists.
Yes, there. I've actually learned about these from John and Laura, my teammates here at NOAA, my leaders here at NOAA, I should say. They help guide me on a daily basis. There have been a lot of great resources online that they've shared with me. Some of them, like Zooniverse, which is a great website for contributing to citizen science programs, and the span and diversity in programs. You can go in and specialize in programs that you can contribute to remotely. We support programs here with NOAA, or we participate in programs with NOAA where you're able to contribute as a citizen scientist from your home by watching things on your computer screen. So Zooniverse is a great resource. Citizenscience.gov is also good. You're able to search and look at programs based by government agencies. So if you're interested in NOAA specific projects, you're able to go in and see those as well.
All right, our next question is from Jennifer, and she asks, can you give some examples of how NOAA is using citizen science to collect data? Are there any long-running projects?
Absolutely. NOAA has, I mean, I'm still learning about a lot of them, but NOAA has a lot of great programs, especially ones that have been going on for a significant period of time. COCORAS, trying to remember the acronym, Community Collaborative Rain, Hail, and Snow Network, collects weather reports from across the country, and they help to, contribute to weather modeling and data. And many people may or may not know, but weather reports were the first form of citizen science. This is not a new study. Citizen science has been going on in the United States, at least for hundreds of years. It started with, I believe it was Thomas Jefferson was asking folks to send in the weather they were observing in their area. And some of those historical records are still being kept at the Smithsonian. But the COCORAS program within NOAA has been going on for several decades. And it's, we're collecting weather reports from across the country in every state. And it's has a long-standing record. If you haven't checked it out, I definitely encourage you to look into that project. I'm trying to figure out how I can type that in, or just I believe it's COCORAS, COCORAHS.org. It's an awesome program that's been going on for several decades that NOAA's been working with. And I'm sure they could always use more contributors, especially if you live in urban areas and you're able to collect that data. I think it would be a great asset.
Absolutely, Rebecca. And I just put the website in the chat. It's cocoras.org. It's a very fun website to check out. Definitely take a look at it. So our next question, though, says, can you think of any areas within NOAA that could really benefit from using citizen science, but maybe haven't utilized it yet?
Oh, I mean, citizen science within NOAA is they have a great diversity in regions, or in projects. There's COCORAS that's looking at weather and weather patterns and observations. There's also bathymetry projects mapping the sea floor. There's fisheries projects with the shark tagging as well as horseshoe crab tagging. So there's really anything that involves atmosphere or oceans. I feel like there is a citizen science project for it. I recently found a news article about a project out now through the extreme weather. where they're asking folks to report their observations after going through a catastrophic tornado in an attempt to help improve the weather readiness and weather alert system. So there's a lot of diversity in the citizen science programs within NOAA. I feel like any corner you want to look in, there's something for everybody.
Great. Thank you so much, Rebecca. We have a couple more questions here. This next question asks, what are 2 or 3 readings you would recommend for a beginner looking to learn about citizen science? And this may be something that we want to follow up with afterwards. We can send some links after the presentation ends if you want, but I'll turn it over to you now, Rebecca.
Absolutely. I would be more than happy to share out some links. There are a lot of helpful articles that I read when going through my master's project and trying to pull these resources together. Some of them were just identifying barriers that kept folks from participating in citizen science because it's really something that everybody can contribute something to. The Environmental Law Institute, they have two of the things I mentioned earlier, which is their case study, and it shows you what a citizen science project can look like broken down by category, whether it's air, soil, or water. So that's really nice to see example projects. They also had a tool that I thought particularly was interesting because a lot of scientific research, especially pertaining to government agencies, can get very jargon heavy. And if you don't have a science background, that can be very intimidating. And when you're trying to work with communities or folks that don't have a formal education in science, sometimes that content's going over their head and they might not feel as inclined to participate. It could also be very intimidating. But the Environmental Law Institute came up with a almost like a glossary or a dictionary of common terms that broke down what they were looking for. It gave a really detailed explanation in layman's terms, but it also broke down some of the laws and policies behind environmental science and citizen science. So it was a great introductory tool for kind of decoding the world of environmental science and policy and making it very digestible and understandable to anybody. And even I have a bachelor's degree in wildlife and fisheries. I still referred to that PDF document a lot when I was looking through different, particularly policies and procedures. So that one was really helpful. The Environmental Law Institute, they had a lot of great tools for citizen scientists.
Awesome. Thanks so much, Rebecca. All right, we have a couple more questions. This next one says, is your project planning tool available for the public or only through those working with NOAA?
Oh, and I definitely would be happy to share this with anybody. I created it for my master's project and with the hopes that could possibly be used or be viewed as a tool or an asset to help anybody interested in starting a project. So that's something I can share out if anybody would be interested in utilizing it.
Okay, we have one more question. This question, let me get it up on the screen. This question says, what do you find is the best medium for recruiting the public at large? For example, media, social media, posters, websites?
Absolutely. That's a great question. And it might just depend on what kind of data you're collecting or what type of audience you're trying to reach. We have projects that we collaborate with, such as the Herring Run project up in New England, where folks are able to participate in remotely, watching fish counts in front of cameras. That's an easy one to connect people with. I've actually seen on Instagram Reels, of all things, people are getting really excited about this project over in Europe, where you can watch fish swim up to fish passageways along dams, and observers watching the camera can push the button to raise access points for fish to go up the passageways. So there's a lot of different ways to connect. I think social media can be a very valuable tool because whether or not we want to admit it, a lot of us are connected to the social media platforms. I actually signed up for a citizen science project with my local river keepers group, looking for somebody to collect water samples along the Potomac River this week. So social media, getting into community groups, especially communities that are being impacted by some of these issues. Where I'm at, there's a lot of acid mine drainage, as well as some other water quality issues going on from developing lands in the area. So the River Keepers group put out a call for volunteers in one of my local community Facebook pages, and that's how they got me hooked. So I definitely think social media could be a very valuable tool. Also, using some of those websites like Zooniverse has been great for finding projects as well as seeing the work that's being done across different agencies and partnerships.